Hello everybody, hello all my friends. Today this is the second session. I also want to share with you the second way for delivering lens formula. Second way for delivering lens formula. So before we start, look at where this drawing here, and let this one, it is the object AB, head of object. Here we have the head of image. Let's call A1 B1, right? So here we have the parallel rays from the object streaks called point P, and here on the center of the lens called point O. So look at clear. Within our drawing we have many triangles, and those triangles, some of them are similar. So the first similar triangle is this one, the triangle AB and O is similar to triangle O B1 A1. Look at well. This triangle ABO is similar to the triangle O B1 A1 is the similar. So that is similar. We have all the proportionality laws or the similarity properties. So the triangle, the side, this one, the head of the image means A1 over B1, the ratio of head of image to the ratio of head of the object AB is equal to the ratio of the image distance, means this distance, or B1 over AO. This is the first great important equation. So second similar triangle, similarly also triangle, this triangle, look at this one. We have a triangle OP and F2. OP and F2 is similar also to the triangle F2 B1 A1. Look where OP F2 is similar to this triangle F2 A1 B1. Yes, similarly triangle OPF2 is similar to triangle F2 B1 A1. Just also say that B1 A1 over this side OP is equal to this distance F2 B1 over this distance over this distance, or F2, right? Or F2, this is the second equation. And then if we look where this length or this side is the same as this side, it means that P is equal to AB. This is the first assumption. Second assumption, from here to here, from A to 0, it is the distance of object, and the AO is equal to object distance, and it is noted by letter U. The third one, from here to here, it is image distance, and it is OB1, and it is equal to V. Again, from 0 to F2, from 0 or length to F2, it is focal length. The fourth assumption, from 0 or F2 is the focal length of the lens. So apart from that, our two equations, we are going to combine two equations. So B1 A1 over B1 A1 over OP is equal to F2 B1 over OF2, and we found that OP is the same as AB. It means that B1 A1, where OP is, we are going to substitute with AB over AB is equal to F2 B1 over OF2. So this equation number 3, we are going to compare with equation number 1. Look at on equation number 1. This one. This is equation number 1. So it means that A1 B1 over AB is equal to O B1 AO. So we are going to take this side and we are going to equalize it by this side from equation, this is side from equation number 1. So F2 B1 over OF2 is equal to, from equation number 1, is equal to OB1 over A0. So this is a very important ratio that will bring up to the final equation. From our assumption here, look at here, we have found that AO is equal to U, AO is equal to U, or B is equal to V, and the OF2 is equal to focal length. So we are going to substitute. F2 B1 over OF2 which is the focal length, is equal to OB which is the V over OA which is U. So this is a simplified equation. And again, let us come up to the drawing here. Look at on F2, the length F2 B1 is equal to our drawing F2 B1, this distance from here to here is equal to this distance from 0 to B1 minus the focal length is equal to or B1 minus the focal length, and the OB, remember, is the image distance minus the focal length. This is another great important that we are going to substitute here in our equation. So this equation becomes, where F2B1 is, it becomes F2B1 will be V minus F over the focal length is equal to V over U. Yes. So by crossing or cross multiplication, I found that this equation becomes VU minus FU, which is equal to VF, right? If it is right, let us continue. No question? Yes. So by getting the final formula, what we will do, we are going to divide both sides by the term VU and F. VU and F are going to divide to the both sides, meaning that 1 over VUF multiplied by VU minus FU is equal to VF over VUF. And again, the final step, you are going to see which is right term and be simplified. So F here can be simplified by F, V also by V. Here we remain with 1 over U, and here to here U will go and V will go. Again here F will go and U remain with V. So the final equation will be here, we remain with F, 1 over F minus 1 over V is equal to 1 over U. Look at where 1 over U. Then final equation will be this one. 1 over F minus 1 over V is equal to 1 over U. And by rearranging this equation, we find that 1 over F is equal to 1 over U plus 1 over V. And this one is what we call Renz's formula, and it is what is required. This is what we call Renz's formula and what is required for today. So congratulations to those was ready to this video, and remember to make subscribe. See you on the next session. We discuss on how it can be applied in different equations by solving the problem related to the optics. Thank you very much. Remember to subscribe the video in order to get easily the next session. Thank you.